Today we are going to work on section 4.1, divisibility and factors. So first off, I want to start with a little review, reviewing what integers are. Integers are positive, and negative numbers without decimals or fractions. So basically, they are the number line numbers, the numbers that you see on a regular number line. Then, I know this sounds kind of silly, but let's review what even and odd are. Even means it's divisible by 2. And I know that we know that, but we'll just do a little review on it. A new concept that we're going to talk about is divisible. And what does divisible mean? Divisible is one integer, so a number, is divisible by another number if the remainder is 0. So let's look at 12. 12 is divisible by 2 because I know it goes in there 6 times and my remainder is 0. So it's just a number that goes into another number without any remainders. So let's go on. Okay, now this is where it gets a little bit trickier because these are all divisibility tests that will help us determine if a number is divisible by another number. These are little tricks that will help you out a lot when you're doing your work. Okay, so we know a number is divisible by 2 if the ones digit. Okay, so what I mean by ones digit is we have our place value, we have our decimal, then we have the ones, then we have the tens, then we have the hundreds. So if the ones is ones place, we could have 576. If the ones place is divisible, is an even number, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, then I know that that is divisible by 2. All right, so for number 3, if the sum of the digits, again, each number is a digit, so if you add up those 3 numbers and it is a number that's divisible by 3, then that number will be divisible by 3. So let's take this 576. 5 plus 6 is 11, plus 7 is 18. Is 18 divisible by 3? Yep, because 6 times 3 equals 18. So that means our number so far, 576, is divisible by 2 and 3, because both of them follow our divisibility rule. So let me say that again slower so that you guys can really understand it. I did 5 plus 7 plus 6 equals 18. Then I go to my number 3. The sum of the digits is divisible by 3. So here's my sum of the digits, 18. And I know that 18 divided by 3 is 6. There are no remainders, so that one checks off as well. So far we've got it's divisible by 2 because the ones place is even, and it's divisible by 3 because the sum of the digits is divisible by 3. Okay, so let's go to number 4. The last 2 digits are divisible by 4. So what I'm going to be looking at is the number 76. So I have to ask myself, because those are the last 2 digits here. Okay, 76 are the last 2 digits, 7 and 6. Then I have to see if that's divisible by 4. Let's see, 4 goes into 7 one time, minus 4, 3 left over, 36, and 4 times 9 is 36. So it's divisible by 4 as well, because the last 2 digits were divisible by 4. All right, what about 5? The ones digit is a 5 or a 0. Is that the case in ours? Is the one digit a 5 or 0? Nope, so it's not divisible by 5. Number is divisible by 6 says number is divisible by 2 and 3. So let's see, was it divisible by 2? Yep, we checked off 2. Was it divisible by 3? Yep, we checked off 3. So that means it's also divisible by 6. So again, for that one, I'm looking here. It is divisible by 2. It is divisible by 3. So then I know it's divisible by 6 because 2 times 3 is 6. The sum of digits is divisible by 9. So that means we need to add all of those numbers together. 5 plus 7 plus 6, which gets us 18. We already did that. And is 18 divisible by 9? Yep, because 2 times 9 is 18, so that one checks off. The ones digit for number 10, the ones digit is a 0. Nope, not that one. So our digit that I made up here, 576, is divisible by 2, 3, 4, 6, and 9. So this is what my answer would look like. We are going to go through a few examples, but this table right here is something you definitely need to write down. If I let you use a note card on this test, this is something that needs to go on it. This is very important. It's kind of like a little cheat sheet that will help you with a lot of problems that you're going to be doing. So make sure you take your time, you get this in there neatly. Don't just chicken scratch it, because you will be referring to it a lot when you're doing your homework. Okay, let's try some examples. This says, state if each number is divisible by 2, 3, 4, 5, 6, 9, or 10. Okay, so we have to use our little chart that we had and go through all those numbers. Okay, so is the one digit even? Yes, so I know it's divisible by 2. For number 3, it said the sum of digits is divisible by 3. So I have to see what is 4 plus 6, which is 10, plus 8, which is 18. Is 18 divisible by 3? Yes, it is. So we know our number is divisible by 3. The last 2 digits are divisible by 4. Okay, so let's do 68. We take the last 2 digits. They make 68. Is that divisible by 4? Let's try it out. 4 goes into 6 one time, minus 4, left with 2. Bring down my 8. 4 goes into 8 7 times, and that is 28, so I'm left with a 0. So 68 is divisible by 4, so that means our number is also divisible by 4. 5, the ones digit is 5 or 0. Nope, doesn't follow that. For 6, the number is divisible by 2 and 3. We've got a 2, we've got a 3, so we know it's divisible by 6. Number 9, the sum of the digits is divisible by 9. Well, 18 is divisible by 9, so I know it's divisible by 9. And number 10 says the ones digit is a 0. Is the ones digit a 0? Nope, it's an 8. So this would be all the numbers that 468 is divisible by. Okay, let's try another one. 1118. Let's see. Is the ones digit even? Yep, so it's divisible by 2. The sum of the digits is divisible by 3. Okay, so let's add 8 plus 1 plus 1 plus 1. So 8 plus 3 equals 11. And is 11 divisible by 3? Nope, it's not. Okay, let's look at 4. The last 2 digits are divisible by 4. Is 18 divisible by 4? Well, 4 times 4 is 16 with 2 left over, so I'd have a remainder. It's not divisible by 4. 5. The ones digit is 5 or 0? Nope. 6. The number is divisible by 2 and 3. Nope, it was only divisible by 2. Number 9. The sum of all the digits is divisible by 9. Is 11 divisible by 9? No, it's not. And number 10. Ones digit is a 0? Nope. So 1118 is only divisible by 2. That would be it. So that one was pretty easy. We could go through all of our different steps and see it was only divisible by 2. Okay, the next number we have is 43,542. So again, let's go through our divisibility tests. Is the one digit even? Yep, it's a 2, so it is even. The sum of the digits is divisible by 3. So let's add them up. 4 plus 3 plus 5 plus 4 plus 2 4 plus 3 is 7. 5 plus 4 is 9. Plus 2. 7 plus 9 is 16. Plus 2 is 18. Man, a lot of numbers sure do add up to 18. So does 3 go into 18? Yes, it does. It goes in there 6 times, so it is divisible by 3. What about 4? The last 2 digits are divisible by 4. So that would be, is 42 divisible by 4? Let's see, it goes in there once. Bring down the 2. Does 4 go into 2? It doesn't. So we are going to have a leftover because I'm going to minus a 0. I'm going to have 2 left over. So it is not divisible by 4. And for number 5, 1's digit is a 5 or a 0. Nope. Number 6, number is divisible by 2 and 3. Well, look at that. I've got 2 and I've got a 3. So I know it's divisible by 6 as well. And number 9 says the sum of the digits is divisible by 9. Again, we got 18, and 2 times 18 is 9. So I know that my number is also divisible by 9. And if it's divisible by 10, the 1's digit is a 0. And in this case, it is a 2. So here's my answer. And for number 4, says 2070. All right, so let's go through our problems. 1's digit is even. Yep. 0 is even. Listen to me again. 0 counts as even because 0, 2, 4, 6, 8, 10, 0 and 10 are, they both count. Okay, so 0 does count as an even number. Does the sum of the digits divisible by 3? So let's add up. Basically, 2 plus 7 is 9. 9 is divisible by 3, so yes, 3. 4, the last 2 is 70 divisible by 4. 37 minus 28. I'm left with 2 over, so nope, not 4. 5, 1's digit is a 5 or 0. Yep, 1's digit is a 0. Number is divisible by 2 and 3. Yep, so it's also divisible by 6. Sum of digits is divisible by 9. Well, sum of our digits was 9, so yep, that counts too. And for 10, the 1's digit is a 0. Yes, our 1's digit is a 0. So it is also divisible by 10. So this one was just not divisible by 4. And, yep, just 4. All right, let's try another one. Okay, 3,707. Let's go through them on these. 1's digit is even. Nope. Sum of digits is divisible by 3. 3 plus 7 plus 7. I don't need to add a 0 because it doesn't change my answer. So 14 plus 3 would be 17. Nope, because 17 is not divisible by 3. If I count by 3s, I don't ever land on 17. Okay, let's try 4. The last 2 digits are divisible by 4. Is 7 divisible by 4? Nope, I have a remainder of 3, not 7. Or sorry, not 4. 5. 1's digit is 5 or 0? Nope. 6. Number is divisible by 2 and 3? Nope. Sum of digits is divisible by 9 for 9. Nope, 9 doesn't go into 17. And for 10, 1's digit is a 0. Nope, 1 digit is not a 0. So we would write not divisible by any number. Sorry, this is like a crazy looking S. Not divisible by any number because none of our numbers go into 3,707. All right, now we have a new concept on the next page, so get your notebooks ready. You should be writing all of this down anyways, but this is another very important concept. Okay, we're going to talk about factors. I told you that we're going to be talking about prime factorization. We did that last year in 6th grade. So again, we need to know that a factor is an integer, so a positive or negative whole number, one integer is a factor of another integer if it divides with that integer with remainder 0. Let's just go through some of these. List all of the positive factors of each number. Okay, so this is the one where we would say 20 is 1 times 20, 2 times 10. Then I'm going to go to 3. Does 3 go into 20? Nope. What about 4? Yep, 4 times 5. What about 6? Nope. 5, we've already got down there. 7 does not. 8 does not. 9 does not. And 10 we already have. So then when I write my answer, let's star this. Write your answer from least to greatest. Always write your answer from least to greatest. Okay, so then I would just do 1, 2, 4, 5, 10, and 20. This would be my answer. This is my work that I need to have. Okay, what about 24? 1 times 24. That's always a given that 1's going to go into every one of these numbers. 2 times 12. Does 3 go into 24? Yep, 3 times 8. What about 4? 4 times 6. What about 5? Nope. 6 we already have down. 7, nope. 8 we already have down. 9, nope. And 10, nope. Okay. So then I'll just write my answer. 1, 2, 3, 4, 6, 12, 24. Again, from least to greatest, your answer has to be written from least to greatest. Okay, let's go to the next page. 100. Okay. 1 times 100. 2 times 50. 3 does not go in there. What about 4 times 25? 5 times 20. 6, nope. 7, nope. 8, nope. 9, nope. And 10, yes, 10 times 10. Okay, so how we're going to write this one is 1, 2, 4, 5, 10, 10, 20, 25, 50, 100. Sorry, I couldn't quite fit that one in there. So there's my answer for that one. What about 117? Ooh, this one's tricky. We're going to really have to pick our brains for this one. 1 times 117. I know it's not going to be divisible by 2. Again, I can use my divisibility rules because it doesn't end in an even number. What about 3? To find out if it's divisible by 3, I add up the numbers, 7, 8, 9. So we know it is divisible by 3 because if we add all the numbers and that number is divisible by 3, then I know it is divisible by 3. So now I just have to figure out what is 117 divided by 3. 3 goes in 11 3 times minus 9, left with 2. Okay, 3 goes into 27 9 times, so I can do 3 times 39. Okay, what about 4? Is 17 divisible by 4? Nope. 5, is it divisible by 5? Does it end with a 0 or 5? No, it does not. 6, is it divisible by 2 and 3? Nope. 9, is the sum of all the digits divisible by 9? Well, 7 plus 1 plus 1 is 9. So I know it is divisible by 9. So let's see. 117 divided by 9. 1 minus 2. Oh, sorry. 1 minus 9 is 2. So it would be 9 times 13. And 10, nope. So then we just have to order from least to greatest. 1, 3, 9, 13, 39, and 117. So that's where those divisibility rules will really help us in finding factors. It'll really help us in prime factorization, and that's where we get to make those trees where we have to say 7 times 3 is 21, and then we break it up from there. So this will help us out a lot. We just really need to make sure we're remembering those divisibility factors. I am going to do a couple practice problems from your book. So keep listening if you're having a hard time. Otherwise, you can go on and work on your homework. All right. So I believe on this one I wanted you to do something like 1 through 42 evens. So I'll start off with number 2. Number 2 asks, if the first number is divisible by the second, explain. Okay, so is 37 divisible by 2? So again, we go to our divisibility test, and we say, is the one's number even? Nope. So we know it is not divisible by 2 because, and it says explain, because the ones place is not even. So I know that it is not divisible by 2. Okay, what about 4? 240 by 2. So if I'm going to look at the ones place, it's a 0. Remember I said if it ends in a 0, then it is a yes. It is divisible by 2 because 0, yes, I can't write and talk at the same time. Yes, oh my gosh, that's terrible. Yes, ones place is even. Okay, even though it's a 0 and you're going to think, well, that's not even, it really is an even number because 40 is even, so yes, it is divisible by 2. Okay, let's try number 17. You're going to be doing 18. So let's do number 18. Okay, number 18 says, show all possible ways that each number can be written as the product of two positive factors. So what we're going to be doing is we need to find positive factors. Oh, well, that's easy enough. So we just need to find all the factors. So for 8, it would be 1 times 8, 2 times 4. Does it go in there 3? No. What about 4? We already have it. 5? No. 6? No. 7? No. 8? Yes, we already have it. So for our answer for this one, we do 1, 2, 4, and 8. Again, this is your work. This is your answer. All right, let's not do number 20 because you can do that one on your own. Let's do 22. State whether each number is divisible by 2, 3, 4, 5, 6, 9, 10, or none. Your book might only say 2, 3, 5, 9, or 10. That is not what I want you to do. I want you to do all of our divisibility tests. 2, 3, 4, 5, 6, 9, and 10, or none. Explain some numbers may have more than one answer. So let's look at 22, 111. Okay, so let's go through our divisibility tests. Is the ones place even? Nope. For number 3, if I add up all those numbers, all the digits, is it divisible by 3? Is 1 plus 1 plus 1 divisible by 3? Is 3 divisible by 3? Yeah, 3 times 1 is 3. So yes, it is divisible by 3. What about 4? Is 11 divisible by 4? Again, to see 4, I just look at the last 2 digits. My last 2 digits are 11. So then I say, is 11 divisible by 4? 4, 8, 12. Nope, not 11. So it's not divisible by 4. 5, is the ones place 0 or 5? Nope. 6, is it divisible by 2 and 3? Nope, only 3, not 2, so it's not divisible by 6. What about 9? Do the 3, if I add up all the digits, is it divisible by 9? is 3 divisible by 9. Can I do 3 divided by 9 and get a whole number? No, because 9 doesn't even go into 3. So I know it's not 9. What about 10? Is the ones place a 0? Nope. So the only number that 111 is divisible by is 3. Okay, and I did a bunch of examples of these, so I'm only going to do one from your homework. I think that you can do the rest of them by yourselves. Let's go to 32. Okay, so for 32, it says show all possible ways that each number can be written as the product of two positive factors. So again, we're going to be going through and just finding the factors. So for 28, I would do 1 times 28, 2 times 14, 3, is it divisible by 3? Is 2 plus 8 would be 10. So nope, not divisible by 3, sorry. So again, I'm using my divisibility factors. I'm doing 2 plus 8 equals 10. Is 10 divisible by 3? No, it is not. Okay, what about 4? Is 28 divisible by 4? Yep. 4 times 7 is 28. What about 5? Nope. 6? Nope. 7 we've already got. 8? Nope. 9? Nope. 10? Nope. Okay, so again, I'm going to write my answer 1, 2, 4, 7, 14, 28. Okay, I think the rest are good to go. I'll do number 40. I'll help you out on that one. Okay, so it says 3 box 817. Write the missing digit to make each number divisible by 9. So again, for a number to be divisible by 9, you have to add up all the digits, and they have to be a number that is divisible by 9. So let's do 3 plus 8 plus 1 plus 7. Well, I know 3 plus 7 is 10, plus 8 is 18, plus 1 more is 19. Okay, so I need to find the next number past 19 that is divisible by 9. So 9 times 1 is 9. 9 times 2 is 18. Oh, that's too small. 9 times 3 is 27. Okay, so if I go up by 9s, I have to make this number be 27. So really what I'm asking myself is 19 plus what equals 27? And I know that 19 plus 8 equals 27. So this 8 is going to go into this box. So 38,817 is divisible by 9. Okay, so I'm going to add up all the numbers. So what you'll do for 42 as well. Add up all the numbers. Find the next number. So we got 19 when we added up all of our numbers. And the closest one would be 18, but I can't subtract. I have to figure out what I have to add to those numbers to make it divisible by 9. So if I did 19 plus 8 is 27, I know 27 is divisible by 9, so that would make our original number divisible by 9. Give this your best shot, and if you have any questions, please feel free to come in before school, during lunch, after school. Just please make sure you're seeing me outside of class because I get very busy during class answering lots of questions, and I can give you that one-on-one time if you come before or after school or during lunch. Thank you for watching.